Alright, so this is probably the page that I expect to see more students go back to than any other. This is page 4, which covers dimensional analysis in your interactive notebook. And dimensional analysis sounds more complicated than it is, but it is a new system, so really spend some time getting familiar with the process that we're going to go through here. We use dimensional analysis in chemistry to solve problems that involve a whole bunch of unit conversions. So that's what our first example here is going to have. And I'm going to split the process of dimensional analysis into 7 steps, which is more than we really need, but hopefully separating it into that many steps is going to help you see what's happening at each level and then practice it a little bit more efficiently. So first I'm going to go to the left. On the left-hand side, you should have glued this problem that we're going to start with. We did this one in class. It's a problem that involves a whole lot of unit conversions. It says a water faucet dripped continuously at the rate of 215 drops a minute. The volume of the water drop was found to be 0.050 milliliters. Find the money lost each day due to this leak, given that the city water charges were $85.86 for 5,000 gallons of water, and it reminds you that 1.00 gallons is equal to 3.785 liters. So that's the problem that we're trying to solve, and we're going to take these 7 steps to do it. So the first step in dimensional analysis is to make a list of all of the known conversion factors. And this isn't going to necessarily be every conversion factor that you know, it's just going to be the ones that pertain to the problem. And sometimes those conversion factors will be in the problem. So on the left, for step 1, you're going to see a few conversion factors here. Some of them come from the problem, like there are 215 drops in 1 minute, and one drop has a volume of 0.050 milliliters. And some of them are conversion factors that we already know, like there's 1,000 milliliters in a liter, 24 hours in a day, 60 minutes in an hour. In this particular problem, we have a whole lot of conversion factors to list, and you won't typically need that many, but I figure if the example that we show you takes a whole lot of conversion factors and is a more difficult problem, then hopefully in the future when you're doing easier problems, it'll be a little bit simpler. To step 2. In step 2, you're going to determine what you are converting from and what you are converting to, and this is probably one of the more important steps and one that a lot of students skip. But this is going to help you set up the problem correctly and also know when to stop the problem. So on the left, we're converting from drops per minute. That's what it's giving us, right? And you'll see this at the beginning of the problem. It tells us how many water drops are happening in each minute. And what we're converting to is what the problem is asking us to find. So it says find the money lost each day. So that's going to be money per day. And we'll have to pick a unit for money, which is probably going to be dollars. We'll figure out the number of dollars lost per day because of this water drip. On to number 3. Number 3 says start with the given information that you are converting from. Now we just determined what that information was, so now we're going to start our problem with that. So step 3 is really easy. You'll remember that in step 2 we decided that we were converting from drops per minute, so we're just going to put drops over minute, right? That's 215 drops in 1 minute. And remember, we're writing our conversion factors like fractions here, right? We could just say that 215 drops equals 1 minute, right? But we're going to write them as a fraction like this. We'll do this with all of them, just like we did in step 1. Step 4. So step 4 is the new part. Step 4 is the heart of dimensional analysis. Starting with that given information from number 3, we're going to add conversion factors to this problem, making sure that the units at the bottom of each next conversion factor cancel out with the unit at the top of the previous conversion factor. And then because those units are divided by themselves, we'll cancel them out. So let's go ahead and take a look at step 4 here. So in step 4, remember we started with 215 drops per minute. Now because drops is on top, our next conversion factor is going to have drops on bottom. So if we look back up at number 1, the only other conversion factor that has drops in it is this one right here, and that's the volume of one drop. So we're going to put this conversion factor into the problem. Now, whenever we originally wrote it down, it didn't matter whether this was on top or bottom. And if this was flipped, if it said 1 drop on top and 0.050 milliliters on bottom, we would flip it at this point. But it doesn't. So we're going to put that into the problem here, 0.050 milliliters. per one drop, and then we cancel out the unit drops because we have drops divided by drops. Now we have milliliters on top, so we'll insert our conversion factor with milliliters. That's 1,000 milliliters to 1 liter, again canceling milliliters. Then our conversion factor with liters, 3.785 liters is equal to 1.00 gallons, again canceling out liters this time. This problem should continue on the same line, but I ran out of space, so I'm just going to come all the way down here. We have gallons on top, so I'm going to cancel out gallons on bottom with the 5,000 gallons is equal to $85.86 conversion factor. And now I have dollars on top, and if you think back to what we were trying to find, money per day, I do want the monetary unit, the dollars, to be on the top of this problem, so I'm good. But if I stopped right now, I would have dollars per minute. So now I need to convert the time unit from minutes into days. And in the same way that previously we canceled out the top unit by putting the next one on the bottom, this time we're going to cancel out the bottom unit by putting that unit on top. So I'll just keep the problem going down here. It doesn't matter that I skipped some spaces. And I can take this minutes unit and put it on top. So that's 60 minutes in 1 hour. Now I have dollars per hour. So I'm going to do one more conversion factor, hours to days, hours on top, and then those cancel out. And now I have dollars per day, which is step 5. In step 5, we're going to make sure that the only remaining units are the correct ones for our answer. And so we just did that, but we're going to double check it. Step 5, the remaining units that we're left with are dollars per day, and then I've drawn an arrow all the way back up to step 2, and you'll remember that that's what we were trying to solve for, was money per day. So on to step 6. In step 6, we're going to multiply everything on the top of the problem and everything on the bottom together. And it's really important that you do not round at this point. Just write the big ugly number that your calculator spits out, but don't round anything at this point. So back to our example in question number 6. I've taken all of these numbers on top, 215 times 0.05 times 1 times 1 times 85.86 times 60 times 24. I've multiplied all of those top numbers together and written that here, and I've kept the unit, dollars. On the bottom, I've multiplied all of these numbers together and kept the unit, days. And I haven't rounded right at this point. I have not rounded, I've just left that the way it is. Our very last step is step 7. In step 7, we're going to divide that top number by the bottom number, and then we will round for significant figures. So on number 7, I'm going to take this number and type it into my calculator, divide it by this number. I get this long decimal, and this is in dollars per day because that's the unit that I have. And now I'll round to significant figures. Remember that I'm going to do that based on the measured values in my problem. This 215 drops is a measured value with 3 significant figures. The volume per drop is a measured value with 2 significant figures. The conversion from gallons to liters is probably technically not perfect, but there's 4 significant figures there. So my smallest number of significant figures in a measured value is 2 from the volume of the drop here. So I'm going to round my answer to 2 significant figures. Remember, skip the leading zeros, count 1, 2. Use the next number, a 2, to tell us how to round, which is down. So $0.070 per day is our answer. And that's how you solve that problem using dimensional analysis. The last step on this page is to glue in your Apply Dimensional Analysis worksheet. Please don't forget that this does say Apply Dimensional Analysis, and it's really important that you use dimensional analysis to solve these problems. Even though I know that you can come up with other ways, please use dimensional analysis. And that'll be it for page 4 of your interactive notebook.